close the program of this seminar, we are going to have a discussion panel which will be moderated by Charles Fairall, and the other panelists are Sebastian Gliga, Nadja Wallaszkovits, Jean-Christophe Kummer, Jack Harrison, and Kelly Pribble. Yeah? And the title of the discussion panel is Beyond Baking, Burning. I don't know, maybe not that one. Okay, you will explain better. So please, Charles.
I'm going to stand here because everybody's going to take their turn at the lecture.
Okay, so you will be. You have not been a journalist, but you are a moderator now.
Thank you again for coming along to this session where baking is mentioned. Now, let's be absolutely clear about this. This is not a food program, and furthermore, Laurent made reference there to burning, which apparently we've heard is a Brazilian reference to baking of tapes. They suggest you burn them. Don't do that. Where that comes from is that in the previous session, which you might have come to, where I was talking about the difficulties of playing back old tapes, and presentations before that, of course, this is not new. We are running into difficulty with videotapes and audio tapes, and old films for that matter. All these materials are complex and require precision. They were made to serve a purpose, some of them 60, nearly 70 years ago, videotapes. The purpose was to very often just time shift by a day or a week, or to edit, not necessarily to provide long-term preservation, archival futures for the content. Baking refers to, anybody here who doesn't know about baking, refers to one process that people, practitioners, have found can help. We found that tapes that go sticky are reluctant to move through the precision mechanisms that they need to, sometimes react very positively to being heated. We haven't really fully understood why, we just know that it works. So that's one of the things that we do to try and help old tapes to go through the process of replay so that they can be turned into data, which is so much easier to look after and to use, to disseminate, to give to audiences. So the challenge that we're going to discuss with this panel this afternoon, from different perspectives, the commercial perspective of providing services to people with collections of tapes that have high value, to get them digitized. That's a challenge in itself, running a business, going and finding customers and explaining all of these problems and the cost. And then we're going to look at it from the practitioner's perspective. We have, I should have said, Christophe Kummer from NOA, from a commercial perspective, from a specialist tape alchemy kind of, you don't mind me saying that, Kelly? We're kind of alchemists to some extent. People who have to work with tapes to do their best to make them work in the old-fashioned way. And then Nadja, who is also interested in the science, the fine details of the physics, shall we say, that's involved in making the best job. Then we're going to move on to science. Now, this is a relatively new topic. Has been discussed a bit. We have finally written a journal article on the use of science in archives. Jack and Sebastian and I have an article out at the moment in the Journal of Film Preservation. So Jack is going to talk from a scientist's perspective about the stuff we're doing at the moment to try and understand what it is with these tapes that, at a scientific level, at a materials science perspective, what it is that's causing the problem, so that maybe we can find, although baking sounds great and it kind of does stuff, it's not really a science, it's more of a kind of, some sort of attempt. So we're trying to bottom it down into a more scientific analysis. And then finally we will hear from Sebastian Gliga, who is looking forward, is looking beyond way beyond, actually, where we are at the moment to the potential, and this is only a potential at the moment, this is a lot of work to do, of finding alternative ways of recovering information, not only from magnetic media, but also from photochemical film that cannot be reproduced through the normal methods, either because the materials are too badly gone, or the machinery or the skills to run the machinery have expired. So, without further ado, as I said before, I won't say it again, it just sounds good. I would like to welcome to the lectern Christophe Kummer from NOAA, who will give us his perspective of the current situation and where he sees we will be in the midterm.
So first of all, I have to apologize a bit because I'm jumping in for Heidi here, and Sebastian came to me actually 5 minutes ago and said, "Where is your slides?" So I said, "Well, which slides?" I didn't know about any slides. So what you will see here right now is actually a copy of the slides of the last year's PMC, and I apologize for those who have seen them already, but they show quite well actually where we are and what is the point. If you remember, PMC last year was when the train hit the wall, and I think it's a little bit the same, so we'll just put that one. It gives you it gives you actually an idea about, I mean, the company started actually in 2000, and from 2000 and until 2023, we have set up systems which digitized around 5 million assets. Only between 23 and 25, again, apologies for those who have seen this slide already last year. We have set up systems to digitize about 2 million assets. So this is an really a huge increase to up almost 700,000 actually for factories which have been set up to do something. Yeah? It's not that this is done within that years, it's just the start of the process where we set up this. This is really annoying here. So hopefully this is better, yeah. And the sales funnel is huge, and I'm a bit scared at the moment about the sales funnels because it seems that it comes all true. So looking back into history, we started in 2008 to develop a product which is just an archive asset management system, because we thought already in 2008, by 2012, can you just lower a bit the volume and then it should be better? I'm speaking loud enough, great. That in 2008, we thought, well, it would last 5-6 years, we will be able to sell in just systems. We had this from the perspective of audio. So this is now almost 20 years ago. So this is actually something which gives you an idea. Australia has said 2025 is the end date. After that, we won't do it. GTS now in Australia has, the National Archives of Australia said, well, let's move that please to 2030. That's what they said officially, because we still have things to do. So the point here is, and my commercial view, which is backed up by these millions and millions of hours and machines, which we see worldwide, is I'm not concerned of not having machines. I'm also not concerned of finding VTR players or ATR players. I can name you around Austria, with 600 kilometers around Austria, 5 broadcasters which each have 30 Studer machines and around 100 VTR machines, which are still running in a fairly good condition. Not for all formats. They will have something like 3,000 to 6,000 drum hours. That's the moment where normal broadcast engineers says, yes, after 5,000 hours we have to replace the heads. It's not true. We know from 600,000 hours of ORF, from 120,000 hours of Sweden, from 350,000 hours of Abu Dhabi, we can run the machines in the beta up to 25,000 hours upper drum level time. So this is the reality. You can move the moment when you replace the drum head to a much later position. So I'm not worried about that, as long as, and this is a little bit a pitch towards our solutions, we collect the RF signals from the heads. We collect the interactive status report from the heads. That's why with our solutions you can move the proactive maintenance of head repair towards a reactive maintenance. The proactive was the Sony guideline. After 5,000 hours, replace it. The reactive one is the non-obvious answer, NOA. You move it towards reactive exchange of the drum head. So I'm not concerned about that. What is hitting, and it is something where I completely agree with Bob, what he said today, is that maintenance engineers and the European pension situation. A 2-inch average age maintenance engineer is 82 to 85. A 1-inch is about 72 years old. Pneumatic engineers average about 65. MSW, DVW average is about 58. That's our reality. So they refuse at the specific moment to continue to work because of the pensions. We have seen that there is still engineers around the world who are just willing to work, mainly from countries like Pakistan, Egypt, and India. Why? Because they went tapeless much later, and they don't have a pension system. So all of that gives me the answer that we are good for the next, well, in 2008 we said 7 years. If you ask me now, I would say maybe 5 years. I hope 5 years, because we have business at least for the next 5 years. Yeah. So for that one, I hope. What comes beyond that, we don't know. So we will hit a specific moment, a wall, except if Charles finds some brilliant people and continues to just record all of this for maintenance engineering, then there will be also, maybe we will move that moment even to a later stage. I love the idea of the PSI. I was there. We had a cooperation over 1 year to just to set something up, and I believe in this thing absolutely. My conclusion at the moment is 10 years ago we thought 2025 is the end. Today we have a different view on it, but there is an end. And that's why I pass over. Yeah.
Could you take a seat in the waiting room, please?
Yes.
And we will join together for a discussion at the end.
Yes.
Next we have Kelly Pribble. I think it's fair to say a career-long tape guy. How many tapes have you handled, Kelly?
A couple, a few.
I don't mean today. I'll hand you over to Kelly. Thank you.
Oh, thank you. Thank you, guys. This is a great honor for me to be here. It's my first year at IFTA, and so thank you for the invitation. Over the last 15, 16 years, I became an archivist. Before that, I was a recording engineer. I built studios around the world. I recorded a lot of records around the world. And the digital disruption changed my career quite rapidly in the late 2000s. And so I became an archivist at that point. And there's a bunch of things I'm going to show you that I'm going to briefly just hit on these. And if it hits you, come and see me after, and we'll have a more in-depth conversation about it. But I just want to go through a few things I'm dealing with or I've seen over the past several years. And if you've seen it, please raise your hand so I know I'm not the only one that's going crazy here and pulling my hair out. So issues of mold. Really not a big deal anymore. It looks horrible, but you know, if it's on there for a very long time, like the top right tape, that was about 40 years of mold being active and deactive. I can't say who the artist is, but I could say it is a solo album of one of the Beatles. And it was sent to me in that condition. and I recovered it because this picture on the bottom right is the same tape. And so mold is everywhere. It will eat into your tape if it's there for a long time, but it's easily cleanable and easily remediatable. This is another tape I received from an artist who died, and they had lost his master tapes for decades. And there was this quest on finding this artist's lost masters of his last tour before he died. And that white stuff is salt residue that actually was stored close to the ocean for about 40 years. And over the years, in an open environment, that collected salt. And you can see the bottom left picture, how much it's eaten into the flange. That's how much it ate into the tape. And I wasn't able to rewind these in a conventional way because they would just basically destruct. So I built a machine. I'm not going to show that today because it's kind of a crazy machine. But I was able to recover 36 of 36 tapes they sent me. And we were able to identify all the tapes because this artist never did the same set list twice. And there was a website of all his fans that would actually put his set list of every show, and we were able to identify every single tape by that website. So something different coming in. This is another one that I was really clueless about. And when I saw this, it looked like someone had painted with spray paint a tape. Guess what? It was paint, but it wasn't spray painted. And it took me a while to figure this out. And so what I was able to do, I was able to scrape some of this off. I sent it to a lab. It came back as a metal-based paint or dye, metallic-based paint or dye. And over 40 years, nobody could figure out what it was. So I couldn't figure out what it was, and I had a hunch like, maybe I'm gonna take a piece of the inside of the box, which was dyed white from the original box. And I sent that to the lab. They did analysis on it, and guess what? It came back as a metallic-based dye or paint. So over 40 years, the pigments, not pixels, the pigments of the paint were destructing inside the box and attracting to the magnetic field of the tape, and layer after layer after layer. And so once I was able to figure out what this substance was, I was able to clean it. The bottom right is the clean tape of the 2-inch that you see in front of you. And then I was at the Library of Congress in 2018. I don't know if anybody was at the AES show in Library of Congress in Culpeper in 2018. And I got up and showed some of the techniques and things I do. And about 6 or 8 months later, one of the other engineers that attended said, I think I have something similar to what you have. And he called me and I said, what do you have? Who's the artist? He said, it's Bob Dylan. And so it was the Bob Dylan Center out of Tulsa, Oklahoma, who had bought all Bob Dylan's personal artifacts, lyric sheets and things, and they ran across this issue. And at the time, I first saw this in Brazil, and there was no phrase for this, or was no word for this, and I coined the word adhesion syndrome, because I contacted everyone in the world, and no one had ever seen this except me, so I thought I was going crazy. But then it kept happening and happening, but I didn't see it in the US until this collection of 63 tapes came to me. And that is the bottom left picture is a Bob Dylan tape where you can see the oxides pulled off. I actually currently have a patented process to remediate this. It's been working for about 14, 15 years now, so if I know it's bound with adhesion syndrome, I can usually get it unbound. I have about a 98% effective rate, which is not bad, and I'm able to unbind the tapes. Once this happens, I can't fix it. So if you see this, stop. And if you see it, particularly as you're starting to unwind, I can guarantee you it's going to get worse as it gets closer to the center of the hub. So questions about that real quick before I move on? Good, all right. Shoot. Film, yeah. To be honest with you, I don't know what causes this, except my theory is over a period of time, it's pushing the binder to the outside edges. That's the only thing I can think of because it starts at the outside edges, but I've also seen it in the middle of the tape as well. And so I built a crazy machine about 15 years ago when I got this collection, and I was able to, it's a wet soaking process for a long period of time. It's not really that difficult to do. Like I said, I do have a patent on this process, and it works very well, and I'm able to get most of the tapes unbound. This is another thing that just popped up a few years ago. Anybody know that brand of leader tape? Okay, probably 95% of the tapes in the US use this leader tape, and I never saw this until about 3 years ago. And my process reversed this situation, because if I didn't use my process, it actually took the oxide onto the leader tape in that form of the pattern. And so my process was actually able to get it to release the magnetic oxide and put the ink on the tape. Guess what? It didn't affect the audio. The tape still played perfectly. So pleasant surprise, but this is starting to happen on a lot of tapes, particularly the 34 years old, with this leader tape. And there's also some square leader tape that's little squares of either green or red that does the exact same thing. It's a chemical reaction. I can't get anybody at 3M to talk to me about this because they don't want to have any responsibility for it, just like Ampex doesn't want to have any responsibility for adhesion syndrome, just like everybody else is like, we don't want to comment on that. So this is an issue that's very new. This was another issue that came up to me about 8, 9 years ago. And this is one of my favorite records in the world. That's my album I bought physically there in that photograph. And these tapes had what I call loss of lubricant, is the only thing I can come up with. And in the recipe of the tape, there is a binder, and there's also a lubricant. And I was able to scrape this lubricant off. I sent it to a lab. It made no sense to me, so I called ATR Magnetics, I called RTM, and I said, does this sound familiar to you? And they said, yes, that's the lubricant that was put into audio tape around 1970, 71, when the old lubricant got banned. This is the new lubricant, and right now it's coming to the surface of the tape. The top right picture is 5 minutes of cleaning a tape with a hand little cleaner. And I have to clean the tape about 6 full passes to get enough of it off to run the tape. But I'm also putting Palon on the erase and record head to absorb some of this as it's going through. The bad thing is the 2 bottom pictures, it's eating the aluminum on the head stacks. If you leave this substance on your head stack, I can guarantee you it will eat your head stacks in about 4 or 5 days. And it's gone. And of course, nobody's making head stacks anymore, correct? So an issue that's really starting to come to the forefront, it's natural degradation. This is no one's fault. This is not storage issues, because these tapes right here you're seeing in front of you were in climate controlled conditions the entire life of the tape. So we know it's not conditional of bad storage or neglect. It's actually a natural degradation of the tape, just like I think adhesion is as well. I can't make this happen, put it that way. This is another one, Charles. I wanted to kick off this with you. This is another thing with mold. These are the white specks. Like Charles said, if this gets hard, the tape rips. And so I squirted some solution up there to soften the mold up. And I literally made a machine, so I'm going to go through this really quick. So this is my initial design layout. This is me making some parts. This is an evolution of a part, just to get the sprocket for videotape. And this is some motorization tools I built. I went back to school in 2015 for mechanical engineering because Jeff Bezos doesn't sell what I need. And so I went back to figure out how to build my own machines, and this is one of the first machines I built. And this is the layout for video. But then, as time went on, I wanted to build bigger and better, faster machines and more efficient machines. And so, this is a before and the after on that machine of cleaning a videotape. And my next slide is a little video of that machine in action, I hope. There you go. With the half-inch tape. And then it's going to phase into a brand new machine that just came out of NAB. And then I'm going to cut it short. And that's cleaning on the wet on top of the tape. And hopefully it's going to fade across soon. And that's now my new machine that I built with Cinetech out of the UK that takes all those same techniques into a very nice, the great thing about this machine is, for the first time ever, you can clean a 1/4 inch, a 1/2 inch, a 1 inch, and a 2 inch on the same machine. Never been done before, because you used to have to buy 4 machines, and so this is very accurate at cleaning, and it just came out, a company called Cinetech in the UK. I designed it with them to do what I needed it to do. I'm going to move on. And this is what I've been seeing in the last several years. This is death by tape, I call it, or tape suicide. And this is kind of where I turn it over to our colleagues, Sebastian and Jack, that have started looking at things. And this is my personal motto: it's not rock and roll until you can play it. So thank you guys very much. I appreciate it.
Fantastic. And it takes time to explain these things, and there's so much more depth to it than you managed to. You managed to get across amazing amount of information there in relatively short space of time. So thank you for that. Nadja from Stuttgart Academy of Fine Arts. We heard from yesterday with Christophe talking about the finer details of azimuth adjustments. And is now going to continue talking about some of the other aspects that you encounter when you're trying to reach the perfection that we all would hope for from our moving image and sound collections.
Yeah, so if you thought you have seen some horror pictures before, wait a little bit. This is my life, or a part of my life. A part of my life are what I would say the worst cases. So this is what I found recently in an archive in Central Africa, equator region, close to the seashore. And they call it an archive. The content is really, really, really important. It's about the liberation of this state, about colonialism and so on. So my students are working on this material now, together with the staff in Africa, and we are trying to safeguard these materials best possibly. This will be a little bit of challenge, as you can see. Yes, this is also the way the material is treated there. And if you enter the room, you cannot do it without face mask. You cannot do it without wearing gloves and having a protective coat, because the climate is horrible, the smell is horrible, and nothing is done, no climatization, close to the seashore, 50 degrees centigrade during summer, But these are the other problems we are focusing. We are focusing, for example, degradation of film material. Here you have a nitrate deterioration in the end status, as well as cellulose acetate degradation, and also an advanced status. By the way, this tape is not existing in this stage anymore. It has been digitized successfully without any problems. What is the problem with cellulose acetate? On one thing, certainly the chain scission of the vinegar syndrome, but the second problem, which is underestimated and underrated, is the loss of plasticizer, which makes the material brittle. So like, for example, this. This tape has also been digitized, fortunately. This picture earned a lot of money for audiovisual preservation, because it's on the website. It's on the website of UNESCO, and Dietrich Schüller, my previous boss, and my big mentor, he took this picture to raise awareness for funding for audiovisual preservation. Yeah. Yeah, it's 30 years at least. So this is the easier going. But what is important with this tape? This is not an acetate tape. This is a polyester tape. Wow! It shows the same signs like acetate tapes. What has happened? The tape has a component of acetate in the magnetic layer. So the binder is cellulose acetate lacquer, and therefore the magnetic layer shrinks. So this is something which makes me a little bit worried about future things, as well as what you can see here. This tape is sticky, obviously, but in the next step, you will see that it is not only sticky, but that it is also an acetate tape. So non-back-coated sticky acetate tape. So everything you would not expect. But you have to overcome with these problems. The next thing we have and where we focus is certainly a problem with the machines. This machine is not very old, but it has been stored in my nice little regions. Sorry, this was the wrong. Yeah, so spare parts, lack of spare parts, lack of playback machines, lack of service technicians, lack of knowledge about how to do this. But this is the simple technology of analog audio. We are not yet at video there. Yeah? So when my boss 30 years ago told me the time span for digitization is 20 years, I tell you this should have been digitized 20 years before. And now we need another 20 years to digitize it. I'm sure about that. Yeah, so these are some of the machine horror pictures. So what are possible solutions to physically safeguard cultural heritage objects? Certainly cold storage, expensive, very high energy consumption. Chemical treatments, they are risky and not always successful. Conventional transfer methods into the digital domain. We have lack of equipment, lack of funds, not enough time left. I'm working on another project, a European Union project, which is dealing with metal organic frameworks, MOFs, as adsorbents for chemicals. This is a nice idea, but we are still in the development phase, and when we are ended, I'm not sure if my tapes will survive the end of this development. And now, a future challenge is certainly climate change. And now I hand over to my friends.
Thank you. Please take a seat. Not for the faint-hearted, of the weak of stomach. Sorry if this is putting everybody off. I know from my own involvement with Paul Scherrer Institute that Jack Harrison and later Sebastian will talk as well, have been doing phenomenal work in the area of degralescence, as we like to call it. I don't know, Brecht would know where that came from originally. Yes. Right, Mike Casey, that's right. But anyway, here it is again. So Jack, can you tell us a little about the work that you have been doing in the recent times and some of the things that we've learned through hard science?
Great. Well, so yeah, as you've seen from our friends and colleagues here, there are still very extreme challenges left all over the world to try and save some of this cultural heritage. And really the big question is, if you come across one of these collections, one of these tapes, what should you do? Of course, you can, they've developed excellent solutions for many of the problems. However, in some cases you might try something, it doesn't work, you can damage the tape, you can damage the player. So can we try and take a more holistic view on a collection to try and understand what the problems are and how we can solve them before we even try and make these decisions and go through anything? So I think in order to do this, you need the perspective and the help of the scientists, and that's where we come in. So researchers have developed over the last few decades many different techniques that can solve many different problems. And very often we're just looking for cases to apply them to where we can make a difference. And that's kind of really what brought us into this world, is because we think a lot of the techniques we use can be directly applied to solve your problems. So we like to take a multimodal approach where we use several different techniques that give us a kind of all-over view on the problems a particular tape might face, and that will allow us to kind of try and solve the problems. So I just want to quickly show you two quick case studies of what we've been working on recently to show you where we think we can make an impact. So the first project was in a collaboration with the British Film Institute, particularly Charles. This spun out of the 2023 Theodifter conference, so is a direct output of that. And basically the question is, if we have magnetic film soundtracks, can we put them in the BFI's master film store alongside the film itself? This was not done so far because of fear it might harm the magnetic tapes, but that was the question Charles posed to us. And basically, he sent us some samples of soundtracks that have been put into the film store, some that have been kept outside. I did some analysis, infrared spectroscopy, microscopy, basically showed, as far as I can see, there is no difference between tapes that had gone into the cold storage compared to those kept outside. However, the magnetic properties of the tape actually improve at low temperatures. So storing at low temperatures is actually better for keeping the data safe on the tapes. This has been published recently in the Journal of Film Preservation. Feel free to ask me or Charles about this, and yeah, you can read a bit more about the details there if you're interested. We were also working with David Hadziz from the United Music Foundation on some tapes of the Montreux Jazz Festival archives. These were Pyrrole CJ87 tapes that produced some black residue when he tried to play them back, and he effectively created this new cleaning and heat treatment technique that allowed him to then play them back. But the question was, why does this work? So we set out to investigate. We did, again, spectroscopy, imaging, analysis, and we discovered that, well, we basically confirmed the idea that it was the back coat of the material being imprinted onto the magnetic layer that was causing the issues. So we could understand why the heat treatment was working, why the cleaning was working, and we also diagnosed some other tapes that he had, different types of Pyrrole tapes, that they would also have this same issue. Therefore, you could then put them through this cleaning process comfortably, and you know it would work in that case. So that's a very quick go-through of what we've been working on recently, and I will pass over to Sebastian.
Okay, yeah, thank you very much. It really is a privilege to be here with you as a scientist, as a physicist. So essentially I want to show you some ideas we have for the future of preservation, maybe not preservation, but for recovering these kind of recordings that are essentially unrecoverable. So I'm a physicist, Jack as well. We're from the Paul Scherrer Institute, so we're Switzerland's largest research center for basic sciences. There are about 2,000 people working at the PSI. Essentially, we do many things. This is a very new field of activity for us, so we just started this a few years ago, and this is what I want to talk to you a bit about. So mainly what I'll show you is that we use a particle accelerator that creates X-rays. So here it's a bit like CERN in Geneva. You have a ring, particles are accelerated, and then X-rays are produced. I won't go into details, but the idea is that what we're developing is reading out magnetic tapes using X-rays. So the very simple concept is the following. So essentially we have a very intense and focused X-ray beam, and we can read out the tapes touchlessly. We still have to unroll them, but they don't have to be playable as they would normally be in a Studer, for example, because we're not touching them. The tension is about 10 times less than, at least 10 times less than normal. So this is, let's say, touchless. Here I just want to show you the quality. So in terms of a frequency sweep, we have the top, that's a Studer AA20 output, and the bottom is the raw X-ray signal. And we actually don't measure the entire width of the track, but just 1/100th of that track So it's quite amazing that we get the information out, and then we can do some signal processing, and we get some very nice signals out of it. There are still some differences, but all this is due to electronics. So there's, of course, on the tape itself, we read out the raw signal on the tape, so there's no equalization. And then you see in the Studer, there's like a jump, and that's just a capacitor that charges when you press play, essentially. So the main differences come from the electronics, which, of course, we're just reading the raw signal of the tape. So for this project, we've been working mainly with everybody on this panel, also the Montreux Jazz Festival in Switzerland, and one of the recordings we're looking at is a 1980 recording of B.B. King, one of his concerts, that's actually degrading and cannot be played presently. Okay, so that's a big particle accelerator, but we're also looking at more practical and immediate solutions, and this is with magnetic sensors. So essentially, these are the same kind of sensors you have in hard drives. So we're developing these to fit, well, actually, for tape readout. We're doing this with the people who actually developed this back in the early 2000s and put were the first to put these sensors in tape playback heads. So we're kind of reviving that technology, and essentially this is what the first prototype looked like. Just to give you an idea, essentially you have the waveform signals with these sensors versus a Studer, so very close. The nice thing about these sensors is they're not touching the tape, right? So this is touchless, we're hundreds of micrometers away from the tape. So in the meantime, we've developed this much more. This is the next prototype. Essentially, we kind of redesigned this, so we don't have a motor that pulls and a brake. We really have two motors that are synchronous. There's a force sensor, and there's a feedback between them. Here you see essentially that we're not touching, so that's the distance from the tape. And we also have laser sensors that measure how much tape there's on every pack. So that's essentially to define the speed. So what you're going to listen to here is essentially just some test recordings. These are some frequency sweeps, tones, then a special recording made just for us for tests, and then the first few notes or the beginning of Beethoven's Fifth Symphony. So what you're going to see is the sampling rate is 382 kilohertz here. It's stereo, touchless. Of course, there's no equalization. And here the sensors are still 50 times smaller than the track width. And the new generation we're making, they will actually cover the full width. So you'll see it's not perfect, but we're getting there. And next time we'll meet, you'll see the upgrade. So I'll try to play this now. Yeah. Okay, these are the frequencies. So as you've seen, not too bad. A couple of hiccups, but not too bad. Yeah, and the last thing in the last 2 minutes, we also started reading out motion picture films with X-rays. So this is actually somehow even cooler because we just take the film and we put in the beam. We do tomography on it, so essentially we rotate the film. It doesn't need to be unwound. It stays in the can. You don't even need to open the can and figure out what's inside. So we take thousands of images at different angles. This is like when you go to the hospital, get a CT scan. And then we reconstruct this volume in 3 dimensions. So this is an example. This is actually one of the very first examples. So this is a film roll. It's in 3D. We can extract a single layer. We can virtually unroll it. That's a negative. Then we get the positive. And this was one at the very beginning. So this is not optimized. We're working on this to really get this much more optimized, let's say. And immediately once we did this, I called Charles and I said, oh, do you have any films that would benefit from this? And immediately the BFI said, yes, we have these reels from the shipwreck of the Lusitania. So they were 70 years at the bottom of the ocean. By some miracle, they survived. So the one on the left is very brittle, but it could be unrolled. And the one on the right, obviously, was this big tape reel, or film reel, and it shrunk due to pressure and chemical degradation to this very small object. So yeah, these are the kind of objects we're aiming for at the moment. So yeah, and essentially what we aim to do is to create comprehensive readout solutions for audiovisual media. So as you saw with synchrotron X-rays, with sensors, to really extract the raw signal, and then also for film with tomography. And we're of course also working on software in order to then reconstruct everything, right? I mean, the film from the images and so on. So yeah, that's it. Thank you very much.
See, it's not so bad after all. We have about 10 minutes to discuss. Be great to take some questions as well, but first, before we do that, I'd like to just see if I can start a little conversation here. Christophe, you're confident that, from your perspective, 5 years is probably very realistic.
Yes, for unproblematic formats, not for these formats, of course, but we come more from the broadcast perspective where we have quite controlled conditions, and these horror pictures are typically coming from quite neglected archives and not so much from really well cared of archives, and that is a big difference. Sorry, I did interrupt you. You wanted to make a question.
No, I just wanted you to confirm that. That's not very long at all. So
yeah.
we have some, we have remediation processes that Kelly can use to deal with some tapes, but that's not high volume. It can never be high volume, I don't think. It's a bespoke specialist. You design your solutions to the tapes almost.
Yes, yeah, absolutely.
So you'll carry on doing that for a while, yeah, I guess.
I hope so.
Yes, exactly. So, but again, we're talking about a very sort of medium-ish term proposition here. And then, Nadja, I guess you would say similar kind of timeline, 5 to 10 years maybe for some of those materials?
I need 100 years.
You think 100 years?
Yeah,
Any advance on 100 years?
No, the archives I'm working with, or the small collections,
yes,
they don't even have the knowledge about what they need, and to raise money and to make.
Oh, I see.
Convince.
So it's going to take 100 years to make it happen.
Yeah,
but to find the money for it.
So that doesn't go well with your 5 years. There's a 95-year gap there.
We are two different worlds.
Okay, no, but that's okay. We're just painting a picture here. So then, I think the purpose of this panel really was to shine a light on each of these areas of activity, of demand, huge demand, massive commercial and cultural value attached to it. We're talking about very short-term things here. My question to the scientists, particularly to Sebastian, because Sebastian, you're looking, I know, because we've been talking about future endeavors. Are we going to get there in time to do practical, useful things with science in this area?
Yeah. Yeah, I sure hope so. We're looking to develop these within the next 3 years or so, 3 to 4 years. So yeah, I think we should be then, according to what Jean-Christophe is saying, we should be arriving right at the cutoff, right?
So science comes to the rescue.
hopefully.
I think, talking from my own perspective, where we have, at the BFI, we have very large television collections. The bulk of those television collections have already been digitized, just to kind of put this into perspective. I don't think from large collections, well-organized and most importantly, well-financed collections, that the bulk of materials are still to be done. Unfortunately, also in my experience, is that those collections that have not been done yet are potentially the ones that are going to present the biggest problems. So collections that have not, much like yours, Nadja.
And the lowest funding.
Say again.
And the lowest funding.
Yes, exactly. So actually, there is still a lot of collection of magnetic and film materials that would need to be saved. I mean, film, again, with money provided, can be stored longer term in cold storage. But magnetic materials, they can be stored in cold storage, as we have worked out with Jack, we think. But that doesn't remove the problem of degralescence of the machinery, particularly in the skills. So there have to be big decisions made in terms of priority, I think. And I think that this is more pressing now. This is a more prescient subject now than it possibly ever has been. My kind of final question before we turn it back, hopefully for a question or two from the audience, is what help do the scientists need? What further help do you need to push forward with alternative solutions from this community?
Yeah, so I kind of made an appeal last time at IFTA that if you have tapes that you are going to throw out, for example, that have degradation, we'll be happy to have them. Not 100,000 of them, like maybe one of each or something, right? So that we can conduct tests on them and validate our techniques and so on, right? So actually it was very hard for me to get some sticky shed tape. I had to buy it off the internet from somebody because I didn't really have...
There's a market for sticky shed tape on the...
apparently.
I must get into that business. It sounds very lucrative. Okay. Okay, so how are you going to make that happen? How are we going to do that? How are we going to work in a way that actually yields some results? So maybe I could turn to our delegates here. Has anybody got any ideas how that could happen? How we could channel sample materials of the worst cases? I mean, we've seen examples of them there, so presumably, Nadja, you've got some.
I just wanted to say I can provide you with some more.
Yes, yes.
You already have, yes.
It's true, we got 2 very bad cases from Nadja, yes.
Any takers here, or shall we leave that to maybe your email address will be available, Sebastian?
Yeah.
And Jack, I know you're continuing working in this area as well, but you'll be based in the UK, is that right? Yeah. Okay, do we have any specific questions or areas of concern? Brecht.
Yeah, my presentation during the Joint Technical Symposium a few months ago was partially also about this subject. And I already said it earlier, degralescence is going to strike in the poorest parts of the world first. Because the price I mean, Christophe, I love your optimism, but what you're not mentioning is that the price is increasing of large-scale digitization, and the first ones who have to drop off because they can't pay it anymore are the poorest parts of the world. So de facto, what is happening is that the potential to preserve heritage is increasing the canyon between richer and less wealthy countries. And for me, that is, as a former president of Fiat IFTA, that is one of the questions. How do we make sure that, I mean, Nadja and me have been talking about Guinea-Bissau. I mean, how many people in the room know where that country is? How are we going to deal with this kind of stuff? And besides that, also smaller institutions. Another point that Nadja also pointed out to me at lunchtime. Smaller, I mean, the bigger institutions, the national libraries, the national archives, the big public or commercial broadcasters, okay. But the smaller museums, the ethnographical collections, the smaller libraries, some kind of family collections, a few companies, commercial companies, I think it's this kind of world we have to venture in as well, because those collections have largely been neglected. And we are going to construct an audiovisual heritage that is going to reflect the wealthy part of the world.
I agree. Can I respond to that? Can I respond to that really quick?
Do.
Last month I was in Mexico City with John Kvibe, who has Hey Audio Student Facebook page. If you don't know what Hey Audio Student is, look up his Facebook page. I think there's almost 500,000 members on it around the world, and we lectured in Mexico. I lectured at a university that had never heard of archiving. They have multiple studios and multiple universities and had never heard of archiving. I lectured at Abbey Road Institute 2 nights ago. I had to bring my own analog tape in to show them what an analog tape was and pass it around. And all of a sudden, these kids come up to me after, like, we didn't know that existed. We didn't know archiving existed. And I think if we can implore some universities that actually has some money that could build a program, and my quest right now is to try to find as many universities globally to have some kind of an archiving program, because they probably have a university they go to that hasn't been archived. There could be a church, there could be a small village or something that could be archived, and the money's not going to be going up there because the university will support it, hopefully. And that is something I've been trying to work on, but I had, in the last literally 30 days, 2 universities, or one school and 1 university and 1 very high technical school that had no idea what archiving was. And I think it's part of our job to solve that problem that you just talked about in the poorer countries, that we can have missionary situations, hopefully, from a university, whether it's in Mexico or somewhere, to go to some of these places and hopefully be able to do a missionary-style situation to archive.
Yes. We only have 1.5 minutes left. Laurent is absolutely adamant that we don't overshoot, so please, one final comment, please, from the panel.
Final comment. The final comment is, I'm doing this job since decades, and I'm not seeing an end of it. Yeah, I could repeat, I could clone myself 100 times, or I don't know how many times, and I could travel worldwide and support my my projects. This is only one part of the coin. The other part is politics. Is money is changing. For example, if the government changes, my well-trained audio engineers ready to safeguard this material don't know if they have a job in January. They don't in December. They don't know if they will be employed in January, and things like that. So it's politics. It's yeah.
Thank you.
Yeah,
that's it.
And I would like to comment on my naive optimism, which Brecht just pointed out. When you look at Sudan, for example, where you also have been there in 2008, Sudan in 2008 managed, as the poorest country in the world, to pull up $1 million for the radio archive project. Where there's a will, there's a way. Typically, you see this will only in national bodies. You don't see that in small archives. If the archive is a substantial body of history, then there is a will, there is a way. And we see that really all around the world. But it must have a substantial historical, nationwide importance. Otherwise, you don't get the money. But then there is a chance.
Optimism. Excellent place to finish. Thank you very much. Thank you to the panel. Thank you, everybody here. Back to you. Thank you.